So this is a geometric series, exercise 4.9, okay? Now, first of all, what is a geometric series? A geometric series such as the one in question 4. Alright, so we have 4, 12, 36, okay? What happens is, it goes up by the same multiplication amount each time. So this time, it's been multiplied by 3 each time. So the next number after that will be 108, followed by 324. Get multiplied by 3 each time, okay? And this is what's called a geometric series. In a geometric series, okay, what we have is we have a general formula, okay, and the formula for Tn is a r n to the minus 1. Now, this a r n to the minus 1 represents Tn, okay, and Tn. A is the first one, so A is 4, and R is the amount you multiply by each time, which is 3. Okay? So for example, for T1, it's going to be A, which is 4, times R, which is 3, and it's going to be N is 1 minus 1. It's going to be 4 times 3 to 0. 3 to the power 0 is 1. It's going to be 4. T2 is going to be 4 times 3, 2 minus 1. And that's going to be 4 times 3, which is 12. And then T3 in turn will be 4 times 3 cubed minus 1, which is 4 times 9, which is 36. So you see it works there, okay? Another way of treating a geometric series is like this, where T1 equals T1 equals A. T2 equals AR, T3, AR2, T4, AR4. Basically this formula here. Okay? Now what's asked us to do is find the nth term of the sequence. So the nth term of the sequence is basically ARn minus 1. So what we can do here, A is 4, R is 3. So for question 2, find Tn. So to find Tn, it's basically going to be Tn equals 4 times 3n to the minus 1. And that's your answer there. Or you could write it as 4 times 3 to the n, 3 to the minus 1. And then you can do it as 4 over 3 to the n. Okay, so there's a couple of ways of writing that. Alright, let's try number 6. So we've done 2 followed by question 6. Now, in question 6, we can see that this is also a geometric series. So we have 5 over a followed by 10 over a squared followed by 20 over a cubed. Now, what we're going to realize is that the initial amount, or now they're using the letter A to confuse you, the initial value is 5 over A. Okay? Remember, A in this term is just the initial value. Okay? And then R equals, now 5 multiplies twice on top, multiplies by twice on top, and A on the bottom. So it's going to be R equals 2 over A. Alright, and now we're going to use our Tn formula, which is ARn to the minus 1. And which is going to be A is going to be 5 over A, R is going to be 2 over A to the power of n minus 1. I suppose we could try rewriting it as 5 over A. Now it's going to be 2 over A to the power of n. And then 2 over a to the power of minus 1. Now the thing about to the power of minus 1 is that it's, if I had like, I don't know, 3 over 2 to the power of minus 1, the answer is 2 over 3. So all I have to do is turn it upside down. So what I'm going to get is 5 over a, and I'm going to move this inside, and I'm going to get a over 2. And I'm going to get 2 over a to the power of n. And now these a's interact, cancelling. I can get 5 over 2, 2 over a to the power of n. Okay, so that's pretty good. Now I'm going to try question to verify that and this one's question 8, to verify that a sequence or a sequence is geometric. Now, the thing about geometric series, if I was to take a normal sample, something like this, I don't know, 2, 10, 50, 250, 1250, what we can see is that the multiplication is always the same. It's been multiplied by 5. Now, and we know that this one here is T1, T2, T3, T4, T5. Now, what we need to do with this is we need to, if you ever get T2 divided by T1, gives you 5. T3 divided by T2 also gives you 5. And T4 divided by T3 also gives you 5. So we can see that these are always equal to each other, okay? We can see that the multiplication amount, or the R value is always Tn divided by Tn minus 1. Now, to verify that a sequence is geometric, what we can do is we can put the old T divided by the new T. Okay, so what I'm going to do here is I'm going to do the general formula. So the general formula is Tn. So Tn equals 2 times 3 to the n plus 1. T of n minus 1 is going to be 2 times 3. Replace that n with n minus 1. N minus 1 plus 1 is 2 to the 3n. Now dividing by each other, we get 2. Now, before dividing by each other, I can see that I'd like them to be in terms of 3 to the n only. So I'm going to change this into 2. I'm going to separate out this power. 3 to the n times 3. And that's the same thing as 6 by 3 to the n. So R therefore equals 6 by 3 to the n over 2 by 3 to the n. The R value is 3. So this means that R is a constant, or the value of Tn divided by Tn minus 1 is a constant, hence it's a geometric series. Now let's do question 9 and try and verify that the series is not geometric. Look what happens now. So we want to verify that this sequence here is not geometric. So to make sure that it's not geometric, once again, our R value for a geometric series is Tn divided by Tn minus 1. And in this case, what we're going to get is R. So Tn is n squared minus 3. T of n minus 1 is n minus 1 squared minus 3. And what you can say here is that it's going to be n squared minus 2n plus 1 minus 3. And that equals n squared minus 2n minus 2. Now we're going to get R equals n squared minus 3 all over n squared minus 2n minus 2. Now what you can say about this is it's not a constant, therefore it is not a geometric series, a geometric sequence. Okay. Another way of doing that, if you wanted something else to back up basically what you're saying, is that you can find out what T1 is. T1 is n squared minus 3, or 1 squared minus 3 is minus 2. Then you can say T2 is 2 squared minus 3, which is 4 minus 3, which is 1. That's it. And then T3 is equal to 3 squared minus 3, which is 6. And then you can say that T3 over T2 is meant to equal T2 over T1. And then you could say, well, 6 over 1 does not equal 1 over minus 2. Not a geometric sequence. Right? That's another way of doing it. Alright? Okay, so the next one is, in questions 11 and 16, you're given the first three terms of geometric sequence. So we're given T1, T2 and T3. Find the values of x where x is element of R. So what we know is that from the past, T2 divided by T1 equals T3 divided by T2, because they're all being multiplied by R. So both of these equal R. So what I can say next is that T2, which is x plus 4 divided by x plus 1, ends up to be equal to 3x plus 2 over x plus 4. Now we're going to cross multiply this, and you're going to get x plus 4 multiplied by x plus 4. I'm also going to get 3x plus 2 multiplied by x plus 1. Multiply them out, we get x squared plus 4x plus another 4x plus 16 equals 3x squared plus 3x plus 2x plus 2. Then we're going to get x squared plus 8x plus 16, 3x squared plus 5x plus 2, and let's see what we can cancel. We have minus x squared, so it's going to be 0 equals 2x squared. Then we have 5x minus 8x is minus 3x. Then we have 2 minus 16 is minus 14. Okay, look at these numbers now. Here is basically your equation. Just do this two ways, alright? So the reference number is minus 28. 2 by minus 14 gives you minus 28. What two numbers multiply to give you minus 28? Well, it's going to be 4 and 7. So we've got 2x and x in here. Now 2x has to multiply by a number to give you the 4, which is going to be 2. X needs to multiply by a number to give you the minus 7, so it's minus 7. So it's going to be 2x minus 7, x plus 2 equals 0. X equals minus 2, or 2x minus 7 equals 0, 2x equals 7, x equals 7 over 2. Now we're told anything about them in particular. They're both element R, so there's two different terms we could have. So it's going to be x plus 1, x plus 4, and 3x plus 2. So if x equals minus 2, it's going to be minus 1. The next one here is going to be minus 2, because, plus 2. And the one after that will be minus 4, because 3 times minus 2 plus 2 is minus 4. We can see that that's a geometric series. The one here, if it's 7 over 2, it's going to be 9 over 2, because 7 over 2 plus 1. And then it's going to be 7 over 2 plus 4, which is 15 over 2. And then the one after that, not 15, 15 over 2, because 7 over 2 plus 4, 15 over 2, and then the last one will be 21 over 2, and the other one will be 25 over 2. And every single time that's been multiplied by 5 over 3 is the common difference R there. Okay, so that's also a geometric sequence. Now, question 7 then. The length sides of a triangle in a geometric sequence, the length of the shorter side is 4, and the perimeter triangle is 19 centimeters. Find the length of the other side. So here we go. Let's make the shorter side here. Okay, so this shorter side is 4. Now, a geometric sequence is basically AR squared. And this sequence is going to be 4, 4R squared. So that's 4R squared, that's 4R. Add them all together. So 4R squared plus 4R plus 4 all ends up to be equal to 19. 19 over your side, we have 4r squared plus 4r minus 15 equals 0. The reference number being minus 60. Minus 60 needs to break up into two things to be separated by 4. So what do we have? We could have 2 by 30, 6 and 10. So it's 6 and 10. So what we can do is break up this into 2r and 2r. And that is going to be plus 10 minus 6. So 2r multiplied by plus 5. And 2r minus 3 equals 10. Or you could do it the reference number way, where you'd break up the 4r into plus 4r minus 4r plus 10r. Minus 4r plus 10r minus 15 equals 0. Then you would have got 4r into I said it's a 6 to get the 4r, so you would have got 2r into 2r minus 3 plus 5 into 2r minus 3 equals 0. And then you would have got 2r plus 5 into 2r minus 3. That's another way of doing it. Now we have 2r equals 3, or 2r equals minus 5, r equals minus 5 over 2, r equals 3 over 2. Now, it can't be a negative number, the length, so 4r rules out the minus 5 over 2. So we got to do next is multiply each one by 3.5, so it's going to be 4 times 3.5, 4 times 3.5 squared. So it's going to be 4, the second one's going to be 12 over 2, which is 6. The one after that is going to be 9. 4, 6 and 9 are the lengths, okay? Now, moving on for question 18. X plus 1, x minus 1, 2x minus 5, first 3 terms of geometric sequence. Find 2 values for x. So, what we have here is going to be, once again, T1, T2, T3, such that T2 divided by T1 equals the same thing as T3 divided by T2. We know that's 2x minus 5 divided by x plus 1. We know the other one is going to be x minus 1 divided by x plus 1. Sorry, T2, sorry. So that's x minus 1 here. That's an x minus 1 over x plus 1. So we're going to get x minus 1 squared equals 2x minus 5 into x plus 1. We're going to get x squared minus 2x plus 1 when we multiply that out. Then we're going to get 2x squared plus 2x minus 5x. Well, we all know that's minus 3x, and then minus 5 by 1 is minus 5. Bring everything over one side. We're going to get 2x squared minus another x squared, which is going to be x squared. 3x plus 2x is minus 1x, and then 5 minus 1 is minus 6 equals 0. Reference number of minus 6, so we're just going to get x minus 3. X plus 2 equals 0, x equals 3, or x equals minus 2. Now what it's asking me to do next is write down the first 4 terms of the 2 resultant sequences. So we have x plus 1, x minus 1, and 2x minus 5. Need to put in my 2 numbers and get the 4th term as well. So these are the first 3 terms. T1, T2, T3, and now I want to find out what T4 is. T1, T2, T3, and T4. So when x equals 3, it's going to be 4, 2, then 3 minus 5. So 2 times 3 is 6, 6 minus 5 is 1. Then the one after that, it's gone down by a half, 2, getting divided by 2 each time, so T4 is a half. Okay, and then next one is when it's minus 2, which gives me minus 1, minus 3, and then we have minus 9, so we're getting multiplied by 3 each time. Next one after that will be minus 27. Okay guys, so that's our questions on exercise 4.9.